Okay, today we are going to look at electricity, and we define electricity as charges in motion. Little review. Who can tell me what a charge is? Sean.
Anything that exerts a force.
Okay, anything that exerts a force. So I'm exerting a force on this table, I'm a charge?
Or with protons and electrons.
Okay. Anything that exerts forces on protons or electrons. What makes up charges?
Protons and electrons. Positives and negatives.
We call them positives and negatives, which are protons and neutrons. And protons and neutrons exert forces on each other. Okay, what do like charges do to each other?
Repel.
They repel. Okay, they exert a force that is a repulsion. And what do opposite charges do? Sean?
Attract.
They attract. Okay, opposite charges attract, like charges repel. And what are ways that we can charge an object? Sean?
Through friction.
What do you do with friction?
You rub two objects together.
So any two objects?
Yep.
Or
You rub protons and electrons together. Don't you?
Close. Okay. They have to, thank you, Daniel, they have to be dissimilar objects. So you're exactly right. Friction is one way to charge them by rubbing two objects, but they have to be dissimilar. What do we mean by dissimilar objects?
not the same.
Different surface.
Okay, you're right, not the same, but in electrostatics terms, what does it mean?
Like rubbing protons and electrons together.
Different charges, maybe?
What about the different charges?
One's protons, one's electrons.
One likes to
Positive.
one's
get electrons, and the other one likes to do what? Get rid of the electrons. They like to share. One gets rid of and one takes. And that's two dissimilar objects exerting forces on each other. Okay? Based on these forces and these charges, we're going to look at the electricity, which is the charges in motion. Now, to help us understand electricity a little better, the first thing we're going to do is look at what arrangements light bulbs can be put in that will affect their brightness. So on our lab that we're going to start today, first thing I want you to do in your box of materials is each of you get out one light bulb, one piece of wire, and one battery. Yes, each one of you. Now, for the first part of the lab, with that one wire, the one battery, and the one light bulb, I want you to get that light bulb to light 4 different ways. So go ahead and take that wire and get the light bulb to light 4 different ways.
Oh,
Got it.
You sketch these drawings?
And go ahead and sketch the drawings on your lab sheet.
Look at that, Raj.
Touch to the side of the bulb now. But touch the tip of the battery. There you go. Should.
No.
So it's got to go through the bulb.
The second one would just be opposites.
Right. If you
I did this last.
hook it up incorrectly, it will let you know. Okay, now on the light bulb, to get it to light, where did you have to touch the light bulb at?
The metal part.
The side and the bottom.
Okay, so on the light bulb, you had to touch the side and the bottom with one piece of wire.
The end was touching the positive or negative part of the battery.
Yeah.
So your light bulb, one side of the battery had to touch where?
The battery itself,
battery,
and then the other
and then the
side
other
had to touch
side.
the wire.
Had to touch
Okay,
the other
so
side of
the
the
battery touched one side of the bulb, and the other side of the battery had to touch the bottom of the bulb. Excellent. Go ahead and take your bulb and look at your bulb. What is a bulb really, looking at it very closely?
A wire with like.
It's a wire connecting the end.
If you look at real closely inside there, you'll notice it's just a real thin wire. Okay, we call that a filament. The filament in the bulb. And if you notice, if I could get a cross-sectional area, if I could cut that light bulb in half, okay, you would notice that one side of that filament goes and it touches the side of the light bulb. The other side of that filament, it goes down and touches the very bottom side of the light bulb. And to get that light bulb to light, you had to touch one side of the bulb to one side of the battery and the other side of that wire to the other side of the battery. And so if I take my little pointer here, you had to connect one side there and one side there to get that light bulb to light. And what happens is you get a current to flow through that light bulb and touch the other side. Yes?
I couldn't get the light bulb to light, but it got hot. Why did it do that?
That's a very good question. Okay? Now, electricity is moving charges. to get the charges to move, if you look at your battery, one side's marked positive and one side's marked negative. Okay? What do opposite charges do?
Attract.
Yeah.
Yes, they attract. Opposite charges attract. To get those to attract, you had to have a complete path from one side to the other. If you took your wire and instead of touching it to the battery, you attached it from one side of the battery to the other, those electrons went straight from one side of the battery to the other side of the battery, and all the energy they had, guess where it went into? Sean.
Wire.
So we have wire energy.
Oh, into
No.
the chemical.
It went to heat.
Yeah.
It
heat.
went to heat energy and the waste energy in the form of heat, and that's why your wire got hot. So to get your light bulb to light, you need two things. What are the two things you need to do to get your light bulb to light? Yes?
A complete path.
You need a complete path and
A power source.
a power source. Okay? The power source, which is our battery, it gives the charges the energy. That's our power source. Okay? Where does our battery get its energy from? Get its electrical energy from?
Chemical reaction.
From chemical reactions. Okay? So our battery takes the chemical energy from the chemical reaction and converts it into electrical energy. And then the second thing you need is a complete path from one side of the battery to the other. And we call that complete path a circuit.